Well, finally, let's look at an example of a three-dimensional function, and so we can use the gradient as tools to examine its steepest increase and decrease at a given point.
I can't wait.
Okay, well, let's just jump right into this then. So we want to find the directions in which f increases and also the direction in which f decreases most rapidly at a given point. And then we're going to find the derivatives of f in these directions, actually in those directions. That's where it increases the most rapidly and decreases the most rapidly. And when we find the directional derivatives, we'll see how much the change is. And so our function f of x, y, z is sine of x plus sine of y plus sine of z, and we're going to look at the point 0, 0, 0 at the origin. So del f, well, the derivative of sine is cosine, so del f is, and of course the derivative of sine of y and sine of z, they're constants, so they're 0, so we got cosine of x times I, cosine of y times j, cosine of z times k. And that's our directional derivative. And since we all know that cosine of 0, and cosine of 0, they're all going to be 1. So our gradient vector is I plus j plus k. Now what does that tell us? This vector is increasing most rapidly in the direction of I plus j plus k. And it's decreasing most rapidly in the direction of negative I minus j minus k, the opposite direction. So derivatives in these directions are square root 3 and negative square root 3. And I think you can see, because that's just the length of this vector. Since our vector u in that direction is, well, to make a unit vector, we divide just by square root of 3 the length of that vector. So there's our unit vector. Guess I don't really need that. But increasing most rapidly with our unknown unit, square root of 3 of those unknown units, and decreasing most rapidly, negative square root of 3 unknown units. I didn't say, but I guess I could have gone back here and said x, y, and z are measured in inches or meters or something like that, but I didn't. So alright, now we know a little bit about how we can use directional derivatives even to tell us a little bit about functions of 3 variables, even though we can't see them.